All right, so let's go on to a problem that's not quite as trivial here, something a little more difficult. Um, so 1.2, number 40. Find the points of intersection between the parabola y equals x squared plus 2 and the line y equals x plus 4. So I'm going to start off by giving us just a little graphing area so we can get an idea what these guys look like first of all. So here's my y-axis, and we'll go to the x-axis here, going this way, that way, and that way. And we'll count 1, 2, 3, 4, 5, 6, 7. How about 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so I got a number of things going on there. The first one, we might do a few points here. It looks like I can maybe work in this quadrant to do my points. Let's do x, and then we'll do what is x plus 4, and what is x squared plus 2. So I'm kind of creating a table here of values just to get some lines drawn in. I'm not going to do a ton of them. -2, -1, 0, 1, 2. So -2 plus 4 is 2, -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5. So this is my line. 2 plus 4 is 6. And then over here, see if I can kill that real quick. -2 squared is 4 plus 2 is 6. -1 squared is 1 plus 2 is 3. 0 squared plus 2 is 2. 1 plus 2 is 3. And again, 2 squared is 4 plus 2 is 6. So I've got one thing. Let's go -2. So -2 on the x gives me +2 on the y. There's one of my points right there. Okay, for the line. -1, I'm at 3, which is right there. And at 0, I'm at 4, which is right there. And 1, I'm at 5. So my line looks something like this. Boy, that's a horrible line. Let me fix my line because that's the worst line ever. Eraser, there we go. All right, let's try redrawing that guy. Pointer options, pen. All right, so he's going to go something. He's going to go through these points about like that. There's my line. Okay, that is y equals x plus 4. All right, and I wonder if I can change colors here. It'd be nice if I could ink color. There we go. So let's grab a different color. Maybe we'll grab a blue or something. Oop. Pointer options, ink color. Let's go to that's harder to get to than you think. There we go. There's a blue. So now this one, I'm going to do this x squared plus 2. We're going to do that in blue just to make it stand out a little bit. So -2, I'm at 6, which is way the heck up here. At -1, I'm at 3, which is right about here again. And 0, I'm at 2, which is right here. Oops. And at 1, I'm at 3. And at 2, I'm at 6, which is up here again. So this parabola does a number like this. And again, he is y equals x squared plus 2. I can kind of I mean, it's pretty obvious right now that I have a point right here that is an intersection, because when x is equal to -1, this one has a y of 3 and this one has a y of 3. So one of my points is automatically given away. I'm going to do another thing, though. I'm going to go about this a little bit different way and see if this helps us out at all. So let's go over here for a second. Let's say that we take the two values. We have x squared plus 2, and we set that equal. So when I say set equal, I mean I'm going to set it equal to the other one, x plus 4. So if I set it equal, I'm going to move everything around, kind of jumble it up a little bit. So I'm going to move these things from here over to here. So I get x squared, and this will be a minus x. So I get the x over on this side, minus 4, so it's 2 minus 4 is minus 2, and now it's equal to 0. So now I have this equation that looks a little bit different. X squared minus x minus 2 equals 0. I really hope that might factor. So I need a negative 1. Well, factors of this would be 2 and 1. So how about x minus 2 and x plus 1 equals 0? Because x squared plus x minus 2x would be minus 1x. Takes care of that, minus 2. So when I set these equal, I get a value of x equals 2. 2 minus 2 is 0 times this would give me 0. Or x equals negative 1, because negative 1 plus 1 equals 0 times anything would be 0. And those are the two x values where these two equations, these two functions are equal for their outputs. So now I can automatically tell the negative 1 was given away by the graph, but there's also some place, perhaps up this 2 level. I didn't draw this steep enough maybe it comes up here and they cross at this 2 level here. Well, they do, because now all I have to do is take the two values and I can say, well, if x equals 2, then 2 squared plus 2 equals 6, and if x equals negative 1, then negative 1 squared equals 1 plus 2 equals 3. So the 2 points, these are really my y values now, right? They're my y equals x squared plus 2, and for both 2 and negative 1. So one of the points where these two are equal is at the value 2, 6, and the other one where they're equal is negative 1 and 3. And we see the negative 1 and 3 on the graph right here. And the 2, 6 is actually going to be way the heck up here somewhere, but it would be true. So you could try it with the other equation too. You go to the x plus 4 equation and take that 2 value. Well, 2 plus 4 equals 6, and negative 1 plus 4 also equals 3. So we can see the 6 on that function matches the 6 on that function, the 3 on that function, the 3 on that function. There are your 2 points of intersection for these two equations, and the only 2 points, because once these cross, the parabola crosses there. Whoop, let me hit keep there for a second. Once the parabola crosses there, once that parabola crosses there, they're never going to cross again, right? And once it crosses here, they're never going to cross again. So those are your answers there, 2, 6, and 1, 3.